Okay, so this is lesson 15 part 2, and we call it real life graphs. Now, there's two types of questions that we'll look at for real life graphs. The second part is distance time graphs. So we'll look at this bit first. So we have a barrel or a container with water in, and we're going to pour water in at a constant rate, and we're going to do a little graph to represent what this is. So this is the depth of the water and this is the time it takes. So if we are going to fill the container up with water at a constant rate, then you will get a constant filling of water. The depth will increase at a steady rate over time. If we make a hole in the bottom and at a constant rate, the water will start deep and it will slowly go down at a constant rate until it empties. If we change the shape of the container and put some water in, and so this is fill and this is empty. And so we'll do the graph again over time and depth. Now, because the bottom of the container is smaller than the top, it will fill up quicker at the bottom. The depth will increase more quickly at the bottom than it will at the top. So you will get a curved graph like this. And if you empty it, depth and time, it will empty slowly to begin with and then increase faster as it goes on. So let's change the to be this way round. There's the water. So we've got the two graphs. Depth, time, depth, time. Right, so we're going to fill it up. So it takes, slowly fills and then gets quicker. So it's like this. And it empties quick and then slows down. So it's like this. And what they do is I can give you questions where you match the graph with the container. That's all really. So let's do a bit of a weird one to finish this little bit off. So we'll have there. So the container is like this. And you've got a water in there. So what happens with this? And it's only a sketch, so you don't have to worry about being accurate or anything. It's just identifying which is which. So when we're filling, it's going to start slow, then go quick. Start slow, then go quick. Yeah. The middle bit is going to be at a constant rate, and I'll put a little gap there so that we know that it's the three separate parts. And then it slows down. So yeah, you would normally join these up, but for clarity I've left them like that. So what happens when we empty? It starts slow and then goes quick, and then you've got that straight bit in the middle that's constant, and then it goes. So it's completely the opposite. Completely the opposite. And that is all there is to those types of things. I mean, they can vary the shapes and things, but it's just basically matching up the graph with the shape of the container. So now I need a hang on. No. I'm gonna just get myself a graph from somewhere. There. So let's copy that. Go back to where I was. Down there. And paste the old graph in. Right, okay, let's move it across there a little bit. And back we go. Right, now this part is called distance time graphs. So we've got time going off on the bottom here, and we've got distance here. Now this is the distance from home, yeah, and we can have, I'll go 0 there, yeah. So 1, 2, 3, 4, we'll call it 1, 1, 2, 3, 4, 2, 1, 2, 3, 4, 3, 1, 2, 3, 4, and 4 in kilometers. And we start at 8 o'clock, 8 o'clock, and 8:30, 9, 9:30, 10, 10:30, 11, and 11:30. Right. So you can see we're going distance from home or from our starting position, and the time passes by. Right. 9:30. Let's put a proper 3 because I can't see what that is. It's just some nonsense. Right. Okay. Now this is all about Harry on a bike ride. So when we're doing these sorts of things, you can either get two sorts of questions. One is where they give you the information and you fill in the graph, and the other one where there is a graph and you extract the information. Okay, so it says, let's get this a little bigger. Right, here we go. So Harry, he leaves home at 8:15. Good. He takes 1 hour to travel 2 kilometers. Not very fast on his bike, but never mind. He stops for a rest for 30 minutes, cycles another kilometer in half an hour. And what they will do, they'll put minutes and hours and change the way that the time is written from 12-hour clock, digital 24-hour clock. They'll mix it up to try and make it a bit more thinking, yeah. And then goes home and arrives at 11:30. Okay, so let's complete the graph. So what happens? So he leaves at 8:30, 8:15, and he takes 1 hour to do 2 kilometers. So there's 2 kilometers, and from 8:15 to 9:15 is there. Almost, yeah. Then next bit, he takes an hour, stops for 30 minutes. So when you stop, you're not going any further away or closer to home. So it's going to be a horizontal line that represents 30 minutes of time passing. So that's from 9:15 to 9:45. So we need to do a little line like that. Then he cycles another kilometer in half an hour. So half an hour from 9:45, so it's 10:15, another kilometer, so that's there. And then he goes home and arrives at 11:30. So now he's getting closer to home and he arrives at 11:30. So there's the distance time graph of that information. Now they can ask an additional question just for fun. What speed does Harry? I nearly put Henry there. What speed does Harry go on the way home? Right. So we go back to the triangle, the first part of this lesson 15, and we need this, don't we? We need the speed, the time, and the distance. So we're looking for the speed on this journey. Let me just highlight that journey there. So we're looking for the speed on that journey. Now, the speed is equal to the distance over the time. The distance is 3 kilometers, and the time it takes him to get home is from 10:15 to 11:30. So that's 1.25 hours. 1.25 hours, which is 1.25. So you've got to get the decimals again. And that will be 2.4 kilometers per hour. So the other way around they can do this is to, again, the same speed distance graph. And so this time I'll draw the graph in first, and we'll try and answer the questions about it. This will be done for you, so you wouldn't need to go through all this palaver. Yeah, so here's the again, distance from home in kilometers, and we need to go 1, 2, 3, 4, 5, 6, and the time it takes him, or rather the time on the clock, is 8 o'clock, 9, 10, 11, 12, 1, 2, 3. Okay, so let's draw this, that bit. These are always more or less the same shape, these things. Always more or less the same shape. The last bit we need to work out, yeah. The last bit we need to work out. So another bike ride, yeah, another bike ride. Right, okay, so what time did the rider stop? So now we've got the graph in front of us and we interpret the graph. So where you've stopped is where it's a horizontal line. So it looks as though 10 o'clock is where he stopped, and he stopped for an hour. Don't know whether he had a puncture or, yeah, what time did the rider have a puncture? What time did the rider stop for a cup of tea or something? So it stopped at 10 a.m. Okay. What time was it when the rider was 4K from home. All right, 4K from home. So 4K, so let's do a different color, So now 4K is there. So you go along until you meet the line. And then from the line, you go straight down until it gets to there. And that is 11:30 a.m. Okay, now the rider rode home at 4 kilometers per hour. What time did the rider get home? Didn't put a name in, did I? So I've got to keep writing the rider get home. Okay. So, oh no, that's a different thing. Yeah. So, and then complete the graph. Okay, so I'm going to complete. No, I can't complete the graph until I work it out. Right. So we need our little triangle, don't we? We need our little triangle to work stuff out like this. We need. So we're looking for the time, aren't we? The time. So the time is equal to the distance divided by the speed. The distance from where he is at the end of the line to home is 6 kilometers, and the speed he goes, we've been told it's 4. So that equals 1.5. 1.5 hours. Yeah. So 1.5 hours after this point, he arrives home. So that will be from 12 to 1:30. So what time did he get home? 13:30 or 1:30. Both will be okay. And now we've got the chart to fill in. So we go from there down to 1:30, and there we go. That's completed that second one. And that's this little section on the lesson 15, which is the real life graphs.